Hello and welcome to the video overview for NP13 Advanced Number. So let's get started. First of all, let's talk about what we want you to do. First thing is make sure you've got the overview sheet in front of you so that you know exactly what you should be doing and when you should be doing it. We want you to watch the videos that are listed out on the overview sheet. Every single one of them, we want you to complete all the activities. Do not leave anything off so that you can tick off each task and we know that you have fully grasped this topic so that you have mastered this and you can show this and your teacher can check up on you and see how well you have mastered this so that you can take this learning forward. Previously in maths, you would have covered these three modules, and these three modules listed here will be useful for this particular module for NP13. So way back ages ago in medicinal time, you'd have looked at prime factors of numbers where you took a number and you made one of those trees where you looked at how the number divided up, how it broke down, and you drew those lines off and it grew bigger, this tree, until you got down to the prime numbers which you circled. And then you could express how a number was a product of primes, of particular primes. So that's the first thing you need to know. You also need to know about fractions, decimals, and percentages, and how we swap between them, how we can go from a fraction to a decimal. Because this time we're going to be going backwards. We're going to be going from decimals back to fractions. And lastly, you need to think about and remember rounding and how we round numbers to particular numbers of decimal places or particular significant figures. But more importantly for this module, it's all about the error intervals. What would the smallest number possibly be so that it rounded to a particular number? What could the biggest this number could be and still get rounded to a particular number? And if you've got the smallest and the biggest, what is the distance between that smallest and biggest? So let's first of all have a look at objectives 1 to 4, which are looking at prime numbers and how we use prime numbers to solve particular problems in maths. For instance, in objective 3, you'll be looking at how to find the highest common factor and the lowest common multiple. Now, bit of history about prime numbers. Many years ago, we used to think that prime numbers were really quite useless. We had no purpose for them whatsoever. That didn't mean to say people didn't spend time working on prime numbers. You have a picture here of somebody called Littlewood, who at the turn of the 20th century did lots of work on prime numbers, but it was for no application whatsoever. He just felt that he just wanted to play with them. And like Oscar Wilde said about art being quite useless, he felt, and everybody felt that this was quite useless as well. It was just the plaything of mathematicians. In the same way today that we play on Xboxes, back in those times, they used to play with prime numbers. That was until the 1970s, when the internet was beginning to be formed in people's minds, and we needed a way to talk about cryptography, about secret messages. How could we send secret messages from one person to another without those messages being read over the internet? And this way that these clever people came up with was called RSA cryptography. And this used prime numbers front and central. Prime numbers are in RSA cryptography. And that means that today we are using prime numbers all over the internet. If you buy anything over the internet, say you nick your parents' credit card and you buy some things over the internet, you will be using internet security, which uses prime numbers. WhatsApp. WhatsApp, when it says it's end-to-end encryption, it is using prime numbers to encrypt your message. That means that those people down in near Cheltenham at GCHQ, which is that donut-shaped building there where all the spies listen in on people's messages around the world, those people will be using prime numbers all the time. So much so that there are prime numbers that we don't really know about, that we're not really meant to know about because they're like for the spies only and they use them in their encryption and us normal folk aren't meant to know about them. So prime numbers are an absolutely massive area of mathematics, and we're still finding out new stuff about them today. We have this one idea called the Riemann hypothesis, which goes back like a couple of 100 years actually. And Riemann was a mathematician, and he wrote down this idea. And to this day, we're still trying to prove that his idea is true. We keep on finding instances where it's true, and we keep going and we keep going and we keep going and we keep going and we keep on finding more and more instances of it being true. But what we can't do is prove that it works forever. And that's an area of mathematics where there's so many different ways to go with prime numbers. So, what's next? Well, the next objective, objective 5, is all about how we convert recurring decimals to fractions. Excuse me. Previously, we'd gone from fractions to recurring decimals, and we've done that. But this time, we want to go from recurring decimals to fractions. We've got some videos that we want you to watch there, and we want you to complete the tasks on that. Now, this is an area of mathematics that I find is very neat and tidy. If you've ever seen Mary Kondo on Netflix, where she goes on about tidying and how it makes you feel better, this is an area of maths that I'm sure she would very, very much approve of. And then lastly, on to the last two objectives, which is about using error intervals and bounds to work out calculations, to find out what happens to error intervals when we put them into a calculation and see how these error intervals generally tend to get much bigger. Now, this is a really, really important area of maths because this area is absolutely necessary if you are doing something, say, in space or making surgical instruments. Because what we need to do is, if you're doing something for space or for surgical instruments, is have no room for error at all. Well, very, very minuscule. And that means that any numbers that we're using, they have to be measured to any measurements we make is going to be so precise, because when you put these numbers into calculations, like you'd have to do if you're making something, these error intervals are going to get much bigger. And in space, that's a matter of life or death. Or in the operating theatre, likewise, it's a matter of life or death. So if you're doing something like we've got there, space and surgery or anything where you've got precision engineering, this topic is going to be absolutely massive and it's going to be really, really important. So that's NP13. It's a really great topic to do, lots of applications and areas of maths to take this forward. It's up to you now to go away and learn it. Enjoy.